Good morning, students. This video is going for class 9th and I am going to teach you physics. In this particular lecture, we are going to discuss about various graph and graphical methods for equation of motion. I hope that you have solved equations of motion by mathematical method. And what were equations of motion? There were three equations of motion. The first one was V is equal to U plus AT. Second one, S is equal to ut plus half at square, and third one, V square is equal to U square plus 2as. Now students, these are the equation of motion and we have solved it by one method, and that was mathematical method. Okay, mathematically we proved these equations of motion. Now these equations of motion we will prove another time, but by different method, and this method is graphical method. Okay, so for understanding graphical method equations of motion, the best thing is we should learn various graphs. Okay, so I will draw a few graphs and I will explain the meaning of the graph. So the very first graph I am drawing is here. This axis is known as the x-axis. The horizontal one is the x-axis. On x-axis I have taken time, and on y-axis this vertical axis is known as the y-axis, and on the y-axis I have taken the distance. Okay, I am drawing the distance time graph for uniform motion. So when I will draw the graph for uniform motion, so what will be it? It should be a straight line, because as soon as the time will pass, okay, and the body will keep on traveling, so distance time graph is a straight line for a body having uniform motion. This you should remember, distance time graph for a body at uniform motion. For a body at uniform motion. Okay, fine. Now suppose we have to plot velocity time graph for a body at uniform motion. So at x-axis time will remain, at y-axis it will be velocity. So I am drawing the graph for velocity time graph for uniform motion. So when a body is at uniform motion, so it is having the equal speed at every time. Its velocity is not increasing, not decreasing. So for such case, velocity time graph will be parallel to the time axis. Why it will be parallel? Because as soon as the time will pass out, the velocity of the body is not going to change. Okay, suppose this speed is, for example, suppose this speed is 50 km per hour. So right now it's 50, and after 1 hour also 50, 2 hour, 3 hour, 4 hour. Every time the velocity will remain similar, so it will be parallel to the time axis. Okay, this is a very common question which is asked, that a velocity time graph is parallel to the time axis. So which kind of nature of motion is it? So we will say it's a motion for a uniform motion. Okay, it's a graph for a uniform motion. So I hope you understood this. Now I will plot a distance time graph for a body at non-uniform motion. Body at non-uniform motion. So for non-uniform motion, distance, okay, and distance time graph for non-uniform motion. So this can be in this way. Okay, the graph can be the slope. This is known as the slope. Slope can be in this way, okay, or in this particular shape. So what it denotes? It denotes that it's a non-uniform motion. The distance covered out at equal interval of time is not equal. How we can say this? Suppose I divide this graph in equal time slots. Okay, suppose this is how I have divided equal time slots I have taken. Say this is 30 minutes. So in the very first 30 minutes, how much is the distance traveled? Just draw a line and join it to here on the y-axis. So in the first 1 hour or 30 minutes, this is the distance traveled. For the next 30 minutes, how much distance is traveled? Okay, fine. So this is the distance traveled for the next 30 minutes. What is the distance traveled for the next 30 minutes? So this is the distance traveled. Now you can see for first 30 minutes, second 30 minutes, third 30 minutes, the distance is not same. Okay, so there is variation in the distance. So it indicates that this is a distance time graph for a body at non-uniform motion. Now students, I will draw another time graph for uniform acceleration, velocity time graph for uniform acceleration. So this is how it will be. Let us draw this. So velocity is increasing with time, but velocity is increasing by equal amount in equal interval of time. So this, on the x-axis I have taken time, on y-axis I have taken velocity. Okay, so this is going to be like, suppose I have started from here, and this is how the graph will be. So it indicates that as soon as the time has been spent out, the velocity of the body is increasing. You can say that this is the origin. At origin, the velocity of the body was 0. Sorry, not 0. At origin, this is the time is 0. Velocity of the body was, say, u. Initial velocity was u. And as soon as the time has been spent out and we got it to here, the velocity of the body became v. So we can see that there is a rapid change in the velocity as soon as the time was passing out. So this is how the graph for velocity time for a body at uniform acceleration. Now students, one question is being asked in the exams, or I am going to clear it out. So the slope of this velocity time graph, slope, represents what? Which physical quantity is represented by the slope of the graph? So what is slope? Actually you can see this is a particular line which is horizontal one, and this graph is little making an angle. Okay, there is elevation. Okay, this is elevating towards the top. So when such kind of case is there, so we say it's a slope. Okay, slope is moving towards there. Now students, which value is represented by this slope? So I am telling you, as you can see, this slope is increasing the value of velocity with respect to time. So with respect to time, there is increment in the value of velocity. So the slope of graph is representing which physical quantity should be represented by it, because we can see as soon as the time has been spent out, the velocity is increasing. So velocity, change in velocity with respect to time. So this slope represents acceleration. Okay, so please remember this, the slope of velocity time graph represents acceleration. Now students, which physical quantity is represented by area under slope? Area under slope. Now students, as you can see, area under slope. So this is the slope and this is the area which is being covered under the slope. So this particular, as you can see, which kind of shape is this? You can clearly see this is a shape of a trapezium. Okay, there are two parallel sides and there is a little distance between the sides. Okay, which are the two parallel sides? If I give it the name to the vertex, so the parallel sides are OD and AC, and distance between side is OA. So area under slope we can calculate it, because this is the area of a trapezium. So area of trapezium formula you already know. Area of trapezium, area under the slope is area of trapezium, and that is given by half into sum of parallel sides. So parallel sides are OD and AC, into distance between side is how much? OA. Now let us substitute the value. So you will get 1 by 2 OD plus AC. So U plus V into OA. How much is OA? That is time taken, T. So this is U plus V upon 2 into time T. Now students, U plus V upon 2. Initially the velocity was U and finally the velocity is V. So U plus V upon 2 is what? This is the average velocity. So when we are having average velocity into time, so average velocity into time is always the displacement. So students, we have got the answer that area under the slope represents displacement. Okay, so I hope you understood this. Thank you. God bless.